Okay. So we're going to talk about the remainder theorem and polynomials. So basically the remainder theorem says if a polynomial p of x is divided by the binomial x minus a, the remainder obtained is p of a. So basically it's saying that if I am looking for a value, I can solve it instead of using the traditional way of plugging in and multiplying, adding, subtracting. I can solve it using synthetic division. So for not synthetic division, what did I just say out loud? I think I said that right. Yes, I did. Synthetic division. What we did yesterday. You made me second guess myself. Like, did I make up a word? Just how you questioned me. So it says here, if you have x cubed minus 4x squared plus 7x plus 10 was divided by x minus 2, the remainder can be determined by finding p of 2. So I can determine if it's going to be a perfect fit or not by plugging in p of 2. Does that make sense? So whether it's going to divide evenly or I will have a remainder. If it divides evenly, when I plug in 2, I would get 0. If it's not going to divide evenly, when I plug in 2, I'm going to get a number other than 0. Does that make sense? So for example here, I have x minus 2, and x minus 2 means that if I take x minus 2 set it equal to 0, what would x have to be to make this true? 2. So I'm going to plug in, substitute in 2 for x, and I do the math, and I get negative 12. Okay? What that negative 12 tells me is that I have a remainder, and that x equals 2 is not a 0. Meaning a x-intercept, right? Okay. Synthetic division is also a way for you to multiply. I mean, substitute in variables. Not variables, x values. So let's look here. It says, use the remainder theorem to find the remainder when p of x is divided by x plus 5. So if I have x plus 5, the first thing I'm going to do is take x plus 5 and set it equal to 0. So I'm going to take x plus 5, set it equal to 0. So therefore, we're looking for x equals negative 5. Step 2, I'm going to find p of negative 5. I'm going to substitute in negative 5 everywhere that there is a x. So it's going to give me 5 times 5 times 5 is 125. So positive 125. 25 times 7. 5, 175? No. No? Yeah. 175, yeah. Okay, and then 10 times 5 is 50. Okay, so we have 125. What? Here we go. So back to our math. What's 125 minus 175? Negative 50. Plus 50 minus 5. And that means our ending result's going to be minus 5. So therefore, x plus 5 is not a factor. And we would have a remainder of negative 5. Okay. Now, one thing I really wanted to show you is that also with this, just say you wanted to find a value. So let's say you wanted to find p of 10. Can we say 10? Are we okay with that? If I wanted to find p of 10, I can actually use the synthetic division process to find p of 10 without plugging in and having to multiply. How that would work is I would still set it up. I would put 10. I would write out my coefficients, negative 1, negative 7, negative 10, negative 5. And begin. So I'm going to bring down my leading coefficient. And remember, we diagonally multiply, then we add. Diagonally multiply, then we add. So we have 10 times -1 is -10. -7 plus -10 is -17. 10 times -17 is -170. -10 and -170 make -180. 10 and -180 makes, and then therefore my final result would be, there you go. So that would be what P of T is. So instead of you having to do what is 10 cubed, negative 10 cubed minus 7 times 10 squared minus 10 times 10 minus 5, you can also do substitution with synthetic. Does that make sense? Okay. If case not, this is saying this equals -10 to the third minus 7 times 10 squared minus 10 times 10 minus 5. And you're going to get the same result. Okay, how do you feel about using synthetic division to determine if something's a 0, if there's a remainder, or evaluating? Doable? Not doable? Good. Did she take the whole? Okay. Oh,